So let's start the session. Hello all of you, I'm Ashish Bajpayee from IIT Kanpur, and this is the session for week 6 for live session of CFD and return for course. And in the last time we have studied about the code development part for steady state two-dimensional heat equation. This week maybe I'll take the unstudy heat equation part, two-dimensional heat equation unstudy. So let's see. But first let me wait for others to enter to the meeting and question and answers. You can ask your questions in the chat box. Yes. Okay. Is it related to course, or I haven't seen the mail, but it is related to course, or like it's outside the course? Yeah, sure. So then I'll reply you on mail itself, because it's outside the domain for others. Others don't use this radiator. You are audible. Yeah. Okay, let me think. I think boundary conditions should not be directly a boundary condition here, according to me. Like if you are calculating heat flux, then it should be something like Neumann type of boundary conditions. Along with that, there is a specific like this. Suppose this is your domain. So at the end of the at this point you have boundary conditions, okay, but at this point also you assume the same temperature sometimes. So this is called as there is one name I'm forgetting. Actually, I'm forgetting that. There is one particular name about that, in which we assume the same temperature here at this point. Until then, you calculate your heat flux by like assuming the same temperature here. There is one provision in CFD like this, and one of the provision is like you assume the same heat flux from here to here. So Yeah, but I have to look for it, like specifically look for this type of problem. I'll go through your email and I'll update you for sure. Yeah, I hear like discussing these type of problem would be difficult for others because it's a recorded lecture, so they will in future. Okay, Preeti, your audio is on. Please turn off. Yeah, yeah, Chinmay, please continue. Mhm. No, no, just let me know the lecture number. I don't remember the exact. Mhm. Okay. No, Chinmay. Currently, it just tell me. Okay, because it's a recorded lecture. I can't do much. Mhm. Hmm. Mhm. Okay, you share your screen. Fine, it's fine. You share your screen. Maybe currently I don't remember. Yeah. Mhm. Mhm. It's a second point is correct. It's one of the many methods of treating the boundary conditions. So uh, there are method in which we treat we don't make it and we make ghost cells outside the boundary and take it as a like there make a you can say curve kind of thing to balance this phi. So there is a method of ghost cells. You can search it for a boundary. It's a not real cells are there, but there we balance it. There are methods. There are other methods also. There are different kind of methods. I will update. I will let you know on email regarding this. Sure. And that week 5 is there is no question specifically from that. This was the question. Chinmay, I'm asking. This was the question that there are other kind of boundaries conditions as well, or there are other ways to treat the boundary condition. This was your question. Is it clear? Like I told you that about the ghost cells. What happened? Yeah. So there is again I am taking a rectangular control volume, and here suppose I am making the similar kind of cell. I am making this as a ghost cell, and I treat this these boundary condition and the variation between that is constant, and here I assume the values as 0. So there is this type of another way in which you can treat the boundaries. So I'll let you know on email. There are ways. Yeah, if I have time, then I will share. Actually, currently I'm extremely busy. Uh, I'll, as far as I know, I'll let you know. If I got something, I'll send it. Others have questions from the last week or last assignment, anything? You don't have questions, so let me start it by just saying that last week we have done with this equation, which was a steady state equation. So I told you about the code writing part about for this. After discretization, we have done the writing part, and I must clear this that I will go step by step, and till your exam, you will be very handy with these type of codes. I will tell you the simple algorithm code. I will tell you the finite volume, some of the problems, flow over cylinders, writing contours, sorry, making contours, changing it, making subplots, everything on MATLAB I'll tell. So be sure about it and that I will cover everything in that. But I will go step by step so that when you see my lectures or my live sessions at the end of the this course, you will be able to get all the things in the stepwise manner. So last time I took this problem, but this time what I will do, I will add the times time in that and make the problem unstudy. So the problem is now this. So in this, the domain is also moving in time. Time is in the time domain as well as the space. So you assume a grid, uh, uh, space-time grid, in which you are moving in space and values are changing in space as well as we are forwarding in time, because we are starting with some initial values. So we are not at a steady state right now. So we want to reach this steady state, or we want to reach to some temperatures or some values, some other values. That is why we are using this kind of equation. So this is for any problem of temperature in which you are changing the time temperature with time. So you can use it. So how we can the problem will be solved by forward difference method. And one more thing, time is a one-way coordinate. Means we can't go in past. In natural way also I am telling that we can't go in past. So in CFD also we can't go in past. So we can go as I told in the elliptic equation solution in I think week 2, that we can't go in past, and that is why we are using forward difference right now. So time is one way. So this kind of solution will be useful while you solve assignments. And I have also written one code. Last time I also said that I will share in my notes, but that was not possible due to some extremely busy schedule. But this time I have written already a code. I will share it with you for us, like for use to be used in the assignments. You can use it. Okay. So this is called forward step method, and you can ask me questions in between why I am using what. So like we have used ij in space, in generally in CFT we use n for time. Okay, and here n is like n plus 1, n plus 2, and we are moving in this direction. So we have started from time 0 or time 1 according to matter. Time is equal to 1, time is equal to 2, time is equal to 3, and then we moved forward to time at some n, then n plus 1, n plus 2, and uh, we move towards the steady state. So we move towards, or moving towards the steady state, we mostly do it. Sometimes we need the in between values also, then also we can solve this kind of equation. So it's generally we use it. And making every point clear in the notes as well. Okay. dt over dt. Let's discretize it. So as we have discretized the space, we will discretize the time also. But it's a partial differential here. You see, this is a partial differential. So as we discretize the time, or we use the time, then our space domain will remain constant. Because the partial differential, t is a function of x, y and t, suppose, and if we are using this, then these will remain constant. So I am using this in my time discretization. What I will do is I will write t at n plus 1 minus t at n divided by delta t, and delta t is my discretization of time in time step. You can see in how much delta t I am moving from one time step to another time step. That is called as the difference in the time step, which is delta t, and this remain constant with ij. At constant ij I am making a forward move in time. So I hope this is clear to everyone. This discretization is important. Let's write this as first equation. And then d square t over dx square is another discretization in space. Here time will remain constant. So let's see that let me be clear that this is the explicit time step discretization. You can do implicit also, we will take it later, but right now I am taking the explicit one. Explicit means that we know the time, we know the values at previous time step, so we are using those values. So let me write it. T temperature at I plus 1 J. This I made clear in the last time, so I am not again and again doing it. So T I minus 1 comma J. So this is for x, so y also remains constant and t also remains constant. Delta x square. X is the discretization in x, space discretization in x direction. Then similarly we will do the discretization in the y direction according to this equation. So these three terms we want to discretize. This is the second equation, and I comma j plus 1 minus 2 tij plus ti comma j minus 1. Here also we are discretizing in j, so I and t remains constant, so delta y square. This is the equation number 3. I am taking one assumption or one simplification. Let me write simplification. That delta x is equal to delta y, means we have the square mesh, and delta x is delta y are constant here. and I'm taking that as h. Okay, so this is one assumption. We will take down these assumptions also in the later stage. So let me put these three into our equation, and in this equation, and let's see what happens. So del t over del t is t, and here one more thing I want to make it clear that this is at nth time step, because we know the values at n. So that's why I said that this is the implicit or explicit time step discretization. So let me write it. Is Tij n plus 1 minus Tij n divided by delta t plus Ti plus 1 I plus 1 comma j n minus 2 Tij n plus Ti minus 1 comma j n divided by delta x square. I am writing as x square plus again this comes another equation is Ti j plus 1 comma n minus 2 Tij to the at nth time step plus Ti j minus 1 n divided by h square again, because delta x delta y is equal to h is equal to 0. Am I clear till everyone? Because this is important for writing down. So we want to know this. Okay, somebody. Yeah, Apurva. No, it's this kind of governing equation I made. It's fine. It can be like that also, as you were saying. It can be like this also. No, it's correct, Apurva. You just check it. So let me do it for this. So we want to know this Tij, and as he said that you have this that kind of equation, then you discretize accordingly. As I said, follow the same procedure. Follow the code I am writing in such a way as your equation, and you can do it. I'm writing this as another kind of equation. This is the general form of equation, I must say, in which you have diffusion and that time discretization both at the same time. So that is why I said that I'm going step by step. Maybe it's not a general equation. Sorry, maybe it's not the equation as you have read, but just listen to it, and like you can. I'm not solving anything, or I'm not saying that I'm just telling you the procedure to solve the equation. So this is the procedure actually. So this is very important. I'm taking this on the other side plus delta t over h square, and sometimes you have this gamma here. Okay, gamma alpha anything here. So I'm just solving a very general kind of equation in which you can take minus also, plus also. It's your choice. Any kind of equations you can solve. So it's h square I have taken to common. So let me take it as I plus 1 j plus t I minus 1 comma j then plus Ti j plus 1 n plus Ti j minus 1 n minus 4 Tij. This is equal to 0. Oh, sorry, no, yeah. This is what we want to know, and this all things we know. So let me write in a very another general form is Tij at m plus 1 is equal to Tij at m plus this, let me call it as alpha or alpha, as we will write in our code, and this whole thing as a. So this is our equation. This is our equation. So yeah. So previously we have this domain. Okay. At this points we have t is equal to 0, t is equal to 0, t is equal to 0, and this point we have t is equal to 1. We want to do it as I said in the unstudied manner. So we will keep going until that steady state is reached. Okay. Okay, and then so one more thing I want to make clear is that here you will in that we didn't have any delta t, so we don't have to choose any delta t. There was no stability requirements. But here, uh, as all of you know about the CFL number, but here I am not mentioning because it's a very basic kind of problem, and later stages we can use it. But just assume that delta t and delta x are connected, and as we change the delta t, you can take more delta x. So those are connected in such a way that suppose you are taking here as delta t as 1 second for 1 computational second for each time step. So what will happen? Sometimes you will get the values as nan values because of the stability criteria. So what will you do? You will reduce this delta t. I will show you in code also. Sometimes it will show nan values, and it's a it's a, you can say, check in CFD. Sometimes if you get nan values, it's a problem of stability criteria. So let me write it. Reduce the value of delta t. Okay, and try to stabilize the solution. So if you want to stabilize the solution here, stabilize means you want to get some solution or correct solution, then you need to reduce the delta t. Accordingly, your CFL number will change, and your delta x can be increased. So those are all dependent, and those are based on some kind of experience as well. So yeah. So coefficient, I will not write. So previously we used 2 loops. Okay, right now also we will use 2 loops, but with alpha, as I have written this as alpha, this as one of the criteria, and that will change my solution totally. It will change my solution, and let's see at last time what we will get. So I will write a code similar to previous code, but there will be a change, a little tweak in the code, which will change the entire solution, and that you will use for your unstudy kind of problem. So let me share my screen for code. Okay. So are you comfortable with this, whichever I have written? Okay. Any specific problem you guys are getting in your assignments and all? Chemistry, these are previous solutions. Let me write. Say yes. I'm making a new script in which I'm studying diffusion equation. I'm making this. I asked a question that do you guys getting some problem? Until now, whatever I have explained, it was clear or not? Just let me know. Okay. Others? These are clear. Krishna. There are very less participants today. I don't know why. It's due to weekend. Okay. So first we will write as always clear all. Then we will close all, and we will clear the screen. So let me run this section only, and okay, there is some problem. There is some network problem. So there is another window of online MATLAB. I don't want to do it because I'm not comfortable in writing my code online, but because I don't know how it operates, sometimes it's not working. Yeah, I don't know. Okay. Let we will make it copy there. This all I think all of you have understood. Let's wait for this thing. Let me open it again. So do you all have MATLAB? Are you using it for assignments, and are you comfortable with assignment submission and all? Are you using MATLAB for assignment submission? I'm asking this. Anybody can answer. What you are using for assignment submission? I'm asking this. Apurva, Rashni, Preeti. Okay. Where you are struggling, Apurva? Have you practiced the code I gave? I have taken last time. Mm-hmm. Mm-hmm. So, what you did to solve that assignment? What exactly you missed it? Hmm. Okay, coding, discretization, all parts. So I have to cover it fast, I think. Next time, I think this is the rectangular. Week 7 is the next assignment, or week 6? Rectangular grid one. Okay. Okay. Let me. Oh, it will take some time. I think some problem is covering my laptop. Sure, sure. You can. He will not discuss. He will not discuss coding. So, yeah, it is assumed that you know the basic coding part, MATLAB part. So, I don't know how we will tackle it, because I also tried to introduce you to for coding, but it's going very fast there in the course as well. So next time, uh, I'm thinking of using the similar kind of problems for coding, because what I planned it for my course is, I planned that I'll go step by step, so that you will know at the end, you will know the total, you can say, the discretization and everything, and contour making. This lecture also I will cover a lot of things for contour making. But yeah, I know that this yesterday I saw this assignment. It's another, like you can say, it's a level is different. Actually, it's higher level bit, according to as I am solving the problems. So yeah, you will know the basics from my things, but yeah, it's a bit on the tougher side, I must say, because I am applying a constant boundary conditions here, and he is using a different boundary condition at different domains, which will be a bit difficult who doesn't code for them. So yeah, you can try using the similar, because the problems are similar. Just you need to know uh, the boundary conditions are different. CFT is a game of boundary conditions actually. So this okay. Mm-hmm. I understand, but yeah, it will be a bit difficult part sometimes, because you have both kind of boundary conditions here, Dirichlet and Neumann. So this is the Neumann boundary conditions they are applying, and this is the Dirichlet boundary conditions. So both will be a bit difficult, but you try it, and you have my email also. You can ask me. I Actually, I am bound with not solving the assignment question, because you know the general reasons. I wanted to help, but there is some restrictions. This is the reason why I'm not solving previous assignments also. Yeah, approach. Yeah, today I'm telling you about unstudy. So if you get any unstudy problem, you will get it in future. How to make animation, how to make subplot, how to make plots. So some people don't know even how to make plot, which is fine, but I am telling that basic thing. So let me start. Okay, my matter is started. Um, I think it will be clear from the next week as well, because the approach is, yeah, you are absolutely correct, that approach is what is needed. Um, so this is same as the previous code. I will just change one point, and you look and just look for that point change, and then we will discuss for the further code. So number of points, let's take as 51, which is I think same as previous. Previously we took 101 I think, and domain size we have taken as 1 previously also. H will remain same, which is the domain size divided by number of points minus 1, which I made clear why it is minus 1 last time. If you don't know, then what you do, you watch the previous lecture. In the initial part I have told, so I don't have to watch the 2-hour lecture. In the initial part, I think initial 1 hour I told that, or you check it. But yes, right now just look at this. So I am introducing a new variable named delta t or dt here, which we will use. Okay, so let's take a lower delta t right now to solve the problem, which is 10 to the power minus 4, let's say. Okay, and then I will show if we use the higher delta t value, then why our solutions are not converging and error is increasing, or we are getting the null values. So this is the new variable right now which we are getting. And another variable is alpha, as I told. Alpha is what? Delta t by h square. H square is delta x square or delta y square. So let's write it as delta t over h, or you can write h square also. But I am writing h into h because it shows that it's a multiplication of delta x and delta x square or delta y square. So this is how we initialize the problem. Y will be a 2-dimensional array, which is n points. Arrays are here very important. They're like, if you want to save the values, there also you use the suppose you want to save the values at every time step plus each spatial domain. Okay, you have this rectangular domain and you want to save the values at each time step. So you have spatial domain, and at each time step the grid will move. So it will be a 3-dimensional array. So in the space you want to save the value, then move to the next time step. So it will save in 2-dimensional plus 1-dimensional will be added in the time. So it's a 3-dimensional cuboid kind of thing in which you save the value. But for x and y you use the 2-dimensional array. And arrays are very important to understand for solving these type of CFD problems. Every time we use different kind of arrays, and so MATLAB is a game of array or matrix, you can say, multiplication and for solving the CFD problem. So first row I am making it as 1. While new I am again taking it as excuse me, I am again taking it as endpoints. So endpoints is my grid number. Grid will be 51 cross 51 in my x and y, and for that I am making the array named y and y new. Y new will be the new value that I have made clear in the last lecture. So it's also 0 in the starting, and y underscore new is my another first row as 1. So this is same as previous. So another error. So these are just same things and again writing. Here. You can, what you can do is you can do it along with me. if you have MATLAB. Some of you can do it and get the solutions and let me know if possible. You do it. Okay. Other things are same. I will share the code. This until this. I'm sharing it in the chat box. So this code I shared, you can copy paste it and later you can write along with me. Error requirement, as I said, that error requirement is the checking point by which we will check by comparing it. Then iterations is equal to 0. We will start from 0. Then so now I am starting my array, not array, sorry, my loop, which is while loop. As I told, this while loop is used for checking, and as soon as my error requirement is achieved, my code will stop. So everyone knows that why I'm starting these loops for x and y in the domain, in the special domain, to n. So ij I have started. Then I need to write my y new value. Y new will be what? As we have discussed, is y new will be what? Y new will be, as I said, that t new, according to that y new, as previous lecture, let's do y I comma j, and then comes the alpha part. Alpha contains delta t over h square. So alpha I have already written it as delta t over h square. Let's write it here. And we will multiply that alpha with all the values now. So let's write alpha one. Then we will multiply it by each and every element of that array or matrix. So sorry, each and every element of that matrix. That's why I am writing it in this, multiplying in this way. And this comes as y I minus 1 comma j. This is my first neighboring point. There are 4 neighboring points, so I will write all of them. Y I plus 1 comma j plus y I comma j plus 1 plus y I comma j minus 1 minus 4 into y I comma j. So this is the equation at the last we have written, in which it was like t I j, I think, something like that. Right now I am using y only for the new values to compare it with the previous one. So let's wait for just a second and stop presenting it. This is same as previous, so that I am not again and again going on the things. So I will just this alpha part is changed now, and alpha part changing will affect my solution, which you will see, but nothing else is changed much. I could have copied the code, I think, for saving time. But yeah, so these are the codes which I did previously, or you can say when I started my CFT journey. But like I wanted to have share with you a lot of codes, but one thing is my time is really constrained with a lot of things, and another thing, my health is not going okay. So these are the things which are constraining me for doing it. I hope that till next week I'll be more active and doing lot of problems in the CFT with you guys. I'll share some problems and notes, and you can practice those codes. That demands a bit dedication sometimes, because I also forget things. These are the things which are bit easy for me, so I can do it. One more thing I am changing, that this reminder thing. So let me do it and then let me. And one more thing, that you guys are not posting anything on the problems, all on like question answer dashboard. Um, there is one other guy who is also answering in that, so you can post your questions there. There was one negative comment. I don't know. Uh, it was not possible for us to extend the deadline for any assignment submission. It's not in our hand. All the CFD team or this course team, uh, we don't have the access for extending and all. And sometimes it is very difficult for support give support from our side for a lot of things. So it's not on our hand. So you guys can post your questions. Maybe you will get good answers sometimes just click in your mind, and you want to help us in also improving the course content sometimes. So let's run this and see how our code is running now. So something is wrong. Why it is showing somewhere I forgot my semicolon here, that's why it is showing all the values. Let me stop running my code. So let me be clear about this, that alpha, oh, let's do it again. I'm running it again. So it gave me the value in 5000 iteration here. You can see the delta t is 10 to the minus 4, error magnitude is coming this, which is less than the error requirement. That is why the problem is conversed. Domain size is, as I said, 1. Alpha is coming as 0.25. Hence delta t is 10 to the power minus 4. Sorry. Divide by h square. H square is 1 into 1. That is why 1 by 10 to the power minus 4 is something like that. It is coming. And no, sorry, h square is not that. H is 0.02. 0.02 into 0.02, 10 to the power 4 into 10 to the power minus 4. So 1 by 4, 0.25 is coming here. And I is 50. As I said, and iteration is 5706 in iteration we got the value. And j value is 50. Again, endpoints are 51. So we are making the 51 into 51 grid, which is that here it's just treated as double. Double is one form of it, you can say value saving system, and binary is also 50. So our problem is solved. Okay, unstudy problem is solved. But let's plot it. We have not plotted it. Plotting part. So plotting part will remain same. Last time we did x domain is equal to 1 1 2 minus 4 minus into h, then domain is 1 minus we have used mesh grid for generation the mesh in the x domain and y domain. So let me run this. Then we use the control to make the contour. Contour F. Yeah. There is some glitch. Hello, am I audible? Sorry for the glitch. Actually, I'm not in IIT, so there is some problem in the connection. Am I audible? Someone can answer. Then it will be very in the chat box. You can write yes or no. Not audible. Now? Am I audible now? Please confirm. Again, if it is no, then I have to rejoin the meeting. Sorry. Now am I audible? Okay, thank you. Sorry for the glitch. It's a network connection glitch and I'm not in IIT. So we were here at Contour F. So last time also we made vector x comma y, x and y are these domains, and then y are the number of color bars we want to print, and then 12 points we get. Then we use this color bar function. So let's do it. Let's see what's a color bar is coming, and if you have done it, you will know that what's the difference, and you get to know. So this is the color bar which is coming. These are the functions we used. So one is the mesh grid. We want to first make the mesh, and then we want to make the contour of that, and there are lines. These are the 12 lines which if we increase it, supposed to let me do it for 22, and if we increase, then it will again run for the 5000 some iteration, and it will show you 22 lines of again really sorry, again I shared it. Now really sorry for this, and I think I will complete this problem, and I'll just stop the meeting, and I will record for the further uh, code, next code, I will uh, I will record the video and I will put in the session, or you can say YouTube video, the 2 hours, and that I will put all the total video of 2 hours, and that it will be more useful for you instead of wasting time here with me. If you have question, you can ask right now. So in this, what I have done is, from this we have started from contour f x y y, and we have used 12 first, then I have used 22. So let me do it with 12 and run it. So this color bar is coming, and there are lines in the color bars which shows the difference in the temperature at different points. But as in the contour graph, if I want to make more number of lines, or you can say more number of contours, the changing in the temperature, just change it to any value. I changed it to 22, and more number of lines will come into your contours, and you can see the differences in the temperature at the top location and the bottom location. What are the difference? Sometimes you want to extract some lines here. There are ways in which you can do. You can extract lines and plot it, how the temperature is varying in the center line, and here at the center line how the temperature is varying. You can put it like that also. And so this is the way in which you can do the contour. Let me first do this thing. Okay, I am doing it in a command window so that it is not for always. So let's do it. X label is X. Okay. I'm putting it as X. Let's do it. Oh, not possible here. Okay, that was a problem. Okay, let me tell all of you to ask questions, so that we will not waste time, because my network connection is having some glitch. So I will record one more coding session. So this is for the unstudy problem, but one more thing, that this is not the whole code for the unstudy problem. One more code I will record, in which I will tell all the values, like how to plot properly for different time step and 3D array problem, and I'll share that for some 1 hour. I think I will upload that video by tomorrow or day after tomorrow, and like total video of this recording along with that recording. One thing, so this is clear, I think. So in this, if something is not clear, just let me know. So I wanted to make clear about the labels of axes and how to edit the plots, but it's fine. I will do it in the recorded video. So I think, yeah, plotting for the particular time step also I will make it clear in that video. And convection diffusion equation, if possible, I will include that, or I'll take it in next week. Exactly. So this was a part of my code actually for this week only. I planned it, but right now I am thinking of recording it. So you will get that recording. You are getting the YouTube recording videos, no? So in that video, I think for 1 hour I have already covered. After 1 hour, okay, someone is asking to share my code. I'll share it in chat box. You can copy paste it. I shared it already, Jayashri. I think not total. Don't ignore it. I'll share the total code. It's not the total. There are some lines. Okay, there are some line restrictions. So in a step-by-step manner, it is shared. I don't know, there is some line problem in Zoom. Zoom chat box, there are some line restrictions. So you take it accordingly and use it. Although like this video will be shared, you can just write your code. Should I stop, or you want to ask some questions? Because the question asking will be easy for me. As one of you asked, I'll share the code in which you can find the temperature value at particular time step for particular grid, and means particular grid means particular spatial point as well. And I think I will include the diffusion along with convection, that convection diffusion problem along with unsteadiness. That will be like total, you can say it's a generalized form of transport equation. You can use it, which is the form of Navier-Stokes equation. What I can do is how to share the total code. I don't know. In Zoom there are line requirements. I am copying it in front of you. This is copy, but here in the message box there are line requirements. It is shared. Files, I think if I can share a file, anyways it will be shared with you guys. It's fine, you just don't worry about it. Other questions? Should I do it right now itself? Because we have time and I have not covered a lot of things. I don't know. You guys tell me. Okay, I am stopping the meeting and you will find the recorded lecture. Okay.